Yes, welcome back. Welcome back to EDUHUNT IIT and NEET Foundation classes. This is Sukumar, your chemistry mentor. Let's continue our worksheet discussion. We are discussing Redox chemistry worksheet, right? Mains model worksheet. Question number 38. The oxidation number of manganese in potassium manganate. See, there are two things regarding here. See, one is potassium permanganate, KMNO4. KMNO4. Okay, don't forget. Potassium permanganate. Another one is potassium manganate. KMNO4, K2MNO4. You know very well, potassium will be always in +1 state. So, for better understanding, I am removing this as K plus, and the remaining part will be MnO4 negative. You know very well this is called permanganate ion. Permanganate anion. Similarly, if you do that, if you separate two potassium ions, you left with MnO4 2 negative, right? Yes. So MnO4 2 negative. So just like this permanganate ion, that is called manganate anion, manganate. Now what we need? We need the oxidation state of manganese in manganate and permanganate. We did so many times. In permanganate ion, the oxidation state comes out to be +7, right? Try to calculate. Let us say oxidation state of manganese has X plus 4 into each oxygen 2 negative is equal to the charge present on the species is -1. Yes, so X comes out to be +7 here, and there similarly the X, because it is -2, it is a 2 negative charge, so the oxidation state comes out to be +6. That's the difference. So the oxidation number of manganese in potassium manganate asked. So second option. Okay, yes. Next, moving towards next question. In the reaction BaO2 to BaO, the oxidation number of barium, obviously in this way or that way. Say you find two species here, BaO2, and that side you are having BaO. See, this is barium oxide. This is oxide, and for your information, this is a peroxide, barium peroxide. But the point is, we've been asked to find out the oxidation state of barium, but barium is a alkaline earth metal. I have told you in theory class that for alkaline earth metals, the oxidation state will be always +2. So whether it is barium peroxide or barium oxide, the oxidation state will be +2, no change. Then why this question is framed? This question is framed based on that when we look at this barium peroxide, our mind focus more on the peroxide ion. This is peroxide. Here oxygen oxidation state is -1 in peroxide. Oxygen oxidation state is -1, and in oxide, oxygen oxidation state is -2. Here oxygen is in -2, here oxygen is in -1. There is a difference between peroxide and oxide. So there is a chance for us to go for a silly mistake, right? Yes, but the question is not about oxygen. The question is about barium. So barium +2. So there is no change. When barium peroxide becomes barium oxide, there is no change. The oxidation number of barium does not change. Then what is changing here? See, let me tell you this. BaO2, when it becomes BaO plus O2, what happened exactly here? Here it is barium peroxide, the oxygen oxidation state is -1. here oxygen oxidation state is -2 and this oxygen is elemental form, so the oxygen oxidation state is 0. So -1 to 0 is oxidation, -1 to -2 is reduction. It's a redox, but what kind of redox it is? Disproportionation type of redox, right? Disproportionation, when same element oxidizes, when same element undergoes oxidation and same element undergoes reduction. It's a disproportionation type. So point is, what about barium? Barium is no change for barium. The oxidation state of sulfur in the anions. Sulfur in the anions, SO3 2 negative, S2O4 2 negative, S2O6 2 negative. S2O4 2 negative, S2O6 2 negative. The oxidation state of sulfur in the anions follows the order, the correct order. See, you know very well, this is a sulfite anion. Here sulfur will be in +4 state if you calculate. Similarly, Na2S2O4, this is sodium thiosulfate. Here the sulfur oxidation state comes out to be +2. And what about this? Here the sulfur oxidation state comes out to be, let us say, underlined atom, let us say X, the oxidation state of sulfur, let us say X. So 2X plus 6 into -2 is equal to 2 negative. Then 2X minus 12 is equal to 2 negative. 2X is equal to 10 and X is equal to 5. So here the oxidation state of sulfur is coming to be 5. Yes, the point is, so +4 +2 +5. So we've been asked to find out the correct order. So the oxidation state of sulfur here is more than this one, so least this one. So S2O6 2 negative greater than, S2O6 2 negative greater than, where it is? S2O6 2 negative greater than S2O4. No. S2O6 2 negative greater than SO3 2 negative, that is greater than. So the first option is correct. Okay, let's move towards next question. What is the oxidation state of chlorine in ClO3 negative? There is a little bit print mistake, you can ignore it. ClO3 negative. Okay, ClO3 negative, and I explained several times. The oxidation state here will be, here it comes out to be +5, right? Let's calculate X. Let us say oxidation state of chlorine here, let us say X plus 3 into 2 negative is equal to the charge present -1. So X minus 6 is equal to -1, X comes out to be +5. So the oxidation number of chlorine here is +5, it's a right question, yes. Next, +3 oxidation state is most common in, see, the point is, in the case of nickel, the outermost shell configuration is 4s2 3d8. Okay, 4s2 3d8, and in the higher studies you may study that the stable oxidation state and one and only, almost the most common oxidation state for nickel will be Ni2+. So you will find nickel as ion in this state only, generally. Nickel sulfate, nickel chloride, so nickel is, so the common oxidation state for nickel is +2. And for zinc also, see, for zinc the configuration is 4s2 3d10, and you can simply identify, because this, for this stable configuration, zinc only wants to release this 2 electrons in the 4s2. So always zinc you will find in Zn2+ state, and copper has 2 famous oxidation state, cupric Cu2+, cuprous Cu+. Okay, and for iron there is 2 common oxidation states like Fe2+, Fe3+. These are the common oxidation state, and the most stable will be Fe3+. Ferrous, ferric, because the electronic configuration of iron is 4s2 3d, 4s2 3d6, So if the iron lost 2 electrons, these 2 electrons lost and you will get 3d6. But if iron lost 3 electrons, that means 2 electrons from here and 1 electron from here, then you will left with 3d5. 3d5 means half filled configuration. So because of that half filled stability, iron would love to be in that state, like in Fe3 plus state. So the plus 3 state is the most common in iron. Next, the oxidation state of chlorine in KClO4, potassium chlorate, KClO4. If you want to keep this potassium like this, you keep it. Otherwise, you can remove like K. Let us say K plus and ClO4 minus. Okay. So the underlined atom chlorine, its oxidation state, let us say X plus 4 into 2 negative is equal to minus 1 charge present here. X minus 8 is equal to 1 minus X is equal to plus 7. X is equal to plus 7. So the oxidation state of chlorine here is plus 7. See, I have calculated this several times. That's why I made it little bit faster. Okay. Yes. Don't bother about my writing. Okay. Because we did this oxidation number calculation several times. That's why I'm making it little bit faster. Now, in the conversion of Br2 to BrO3 minus, the oxidation number of bromine changes. See, Br2 to BrO3 minus. Here, bromine is in elemental form, that means in 0 state. And if you calculate the oxidation number of bromine here, it will come out to be plus 5. So 0 to plus 5. The change is 0 to plus 5. Yes. The oxidation state of iodine in HiO4, H3IO5 and H5IO6. Let me write this. HiO4, H3IO5 and H5IO6. The point here is, try to calculate the oxidation number of iodine for the first one. For hydrogen 1 plus iodine, let us say X plus 4 into each oxygen minus 2 is equal to the charge. The charge is 0. So 1 plus X minus 8 is equal to 0. Now X comes out to be plus 7 here, right? Here iodine is in plus 7 state. Okay? Iodic acid. The point is, iodine is halogen. Iodine is halogen, and it is for all halogens the valence shell contains 7 electrons, Ns2 Np5. The valence shell of halogens contains 7 electrons, Ns2 Np5, right? Ns2 Np5. That means so the maximum oxidation state is plus 7. Right? So if there is 4 oxygens, with 4 oxygens it has achieved the maximum oxidation state. Then with 5 oxygens, obviously this also will be in the maximum oxidation state, na? Because more than plus 7 is not possible. Listen my words carefully. With 4 oxygens, you know very well, when an element bonds with oxygen, the element will get oxidized because oxygen will grab electrons, you know very well. So this iodine is in its maximum oxidation state plus 7 because of the 4 oxygens. Now what happened here? One more oxygen. Okay, even if one more oxygen came, iodine can't oxidize more than plus 7. So it will be in plus 7 state. Here also it will be in plus 7 state. Okay, so the oxidation state of iodine in HiO4, H3IO5, H5IO6, in all of them, the oxidation state of iodine is going to be plus 7, plus 7, plus 7. Next, oxidation state of oxygen in F2O. We did several times. Here oxygen will be in plus 2 state. Okay, I told you several times. Oxidation state of iodine in IO3 minus, IO3 minus, IO4 minus and Ki. So oxidation number of iodine in IO3 minus. In IO3 minus we did several times, it will be plus 5. In IO4 minus just now we did, it is plus 7, and K plus, alkali metal always plus 1, so iodine minus 1. So plus 5 plus 7 minus 1, and of course I2 also we need here, I2 in 0. So plus 5 plus 7 minus 1, 0 if you look at carefully. Third option is the best option. The oxidation state of phosphorus in H4P2O5, H4P2O6 and H4P2O7. See, I will explain clearly. This is phosphoric acid. This is phosphoric acid. You know, imagine you take, for explanatory purpose, I am taking two phosphoric acids side by side. Okay, I am taking two phosphoric acids side by side. Now imagine you assume to remove a water molecule between these two molecules and join them. You join them. Now you get double bond O, like OH, OH, O, P double bond O, OH, OH. Now what is the formula for this? 1, 2, 3, 4, 4 hydrogen, H4. How many phosphorus? P2. P2. Oxygen 1, 2, 3, 4, 5, 6. Sorry, 1, 2, 3, 4, 5, 6, 7. O7. That's it. H4P2O7. I have explained this same thing in the previous, one of the previous questions also. Now again I am explaining. Now what is the name of this oxy acid? Pyrophosphoric acid, because it seems like when you heat phosphoric acid, it's a fact. When you heat phosphoric acid, you will get this. Pyro means heating. Okay, yes. So obviously what happened? The phosphoric acid, orthophosphoric acid, H3PO4, this is H3PO4. In H3PO4, phosphorus is in plus 5 state, in its maximum oxidation state, plus 1, plus 2, plus 3, plus 4, plus 5, like this, plus 1, plus 2, plus 3, plus 4, plus 5, so plus 5. It means in orthophosphoric acid and pyrophosphoric acid, in both phosphorus is in plus 5 state, phosphorus is in plus 5 state. Okay. Now you imagine, I am saying assume, you assume to remove one oxygen, because now what formula you need? H4P2O6 means you need to remove one oxygen. You remove this oxygen. Then double bond O, OH, OH. Now phosphorus was directly connected. Okay, in the higher studies, in intermediate, second year inorganic chemistry, there is, in second year inorganic chemistry, there is a chapter called 15th group elements, nitrogen, phosphorus, arsenic, antimony, bismuth, like. So in that chapter we are going to study about this 15th group elements, nitrogen and phosphorus and their compounds very deeply. There you will came across this. Okay, there we will study very clearly about these structures. Okay, yes. Now try to determine the oxidation state of phosphorus here. Plus 1, plus 2, plus 3, plus 4. So you know phosphorus bond nothing. So plus 4. So here phosphorus is in plus 4, fine. Yes. Okay. Now what about that H4P2O5? That's entirely different. Now you take orthophosphorus acid. I have explained in one of the previous questions. H3PO3, orthophosphorus will be H3PO3. The oxidation state of phosphorus will be plus 1, plus 2, plus 3, plus 4. Plus 1, plus 2, plus 3, plus 4, plus 4 minus 1 because of pH bond minus 1. So plus 4 minus 1 means plus 3. So in orthophosphorus, see, it will be very clear if you notice H3PO4 orthophosphoric, H3PO3 orthophosphorus. Here phosphorus will be in plus 5 state, here phosphorus will be in plus 3 state. As when the element is in lower oxidation state, as when element is in higher oxidation state, orthophosphoric, orthophosphorus. Now you take one more molecule like this for explanatory purpose, side by side. And as usual, as you did previously, imagine you removed water. It's just imagination, okay? It's just assumption, okay? To derive the structure we need. P double bond O, OH, O, P double bond O, OH, H, H. Now the oxidation state of this central atom will be plus 1, plus 2, plus 3, plus 4. Plus 4 minus 1. So plus 3. Same like that. Plus 3, plus 3. So this also plus 3. Okay. So the oxidation state of phosphorus H4P2O5 is plus 5. H4P2O6, this one, plus 4. H4P2O5, H4P2O5, 1, 2, 3, 4, 5 will be plus 3. Okay, respectively you been asked. So 3 plus 3 plus 4 plus 5 plus 3 plus 4 plus 5. So first option is the correct option. Okay, yes. Question number 49. Which of the following have been arranged in the decreasing order of oxidation number of sulfur? So similar kind of question we solved previously also. Now again, I'll go by from the bottom. So in H2SO5, H2SO5 is the peroxy monosulfuric acid. You know very well. This is a sulfuric acid. This is H2SO4. H2SO4 sulfuric acid. Now H2SO4, H2SO4 is sulfuric acid. Now H2SO5 means one more oxygen. Now where to add one more oxygen? Yes, that's the peroxy bond. Okay, but getting a peroxy bond doesn't change the oxidation state of sulfur here, na? Because so the connections are same as it is. So you will get sulfur oxygen state as a plus 1, plus 2, plus 3, plus 4, plus 5, plus 6. Here it is plus 6. And sulfurous acid we did several times. Here sulfur comes out to be plus 4. And here sulfur comes out to be plus 2. And here hydrogen sulfide, sulfur will be in minus 2. So I think this is the correct, the decreasing order, plus 6, plus 4, plus 2, plus. So no need to check other options. So for better clarity, let's check. This is sodium tetrathionate. We did several times. Sulfur will be in 2.5 oxidation state. And this is a pyrosulfuric acid. We did previously. Sulfur will be in plus 6 state. So this is wrong. We need decreasing order. Here sulfur will be plus 6. SO2, sulfur will be plus 4, this is minus 2 and again plus 6. So that's why this wrong. This part leads to wrong answer. SO2, 2 plus, this is wrong thing typed, so leave it. So here sulfur will be plus 6, here sulfur will be plus 4, here sulfur will be plus 6 again. So all these first option, second option, third option are wrong. Our correct answer is the fourth option. Highest oxidation state of manganese is present in. So this is potassium permanganate. I explained in the previous question, plus 7 state. K2MnO4, potassium manganate. Here manganese will be in plus 6 state. Mn2O3. Here manganese will be in plus 3 state. Just by the look I identified, because 3 oxygens, each oxygen require 2. So 3 oxygen means 3 2s are minus 6. So obviously 2 manganese will contribute plus 6. So each manganese plus 3, or you can calculate, you get 2x plus 3 into minus 2, that's what we said, is equal to 0. So 2x minus 6 is equal to 0, x is equal to plus 3. What about MnO2? In MnO2, manganese will be in plus 4 state. The highest will be the first option. Highest will be the first option. Yes. Chlorine is in plus 1 oxidation state. See, here chlorine will be minus 1 state, here chlorine will be in plus 7 state, here chlorine, ICl, interhalogen compound, iodine will be plus 1, chlorine will be minus 1, because compared to iodine, chlorine will be more electronegative, na? Now, Cl2O, oxygen will be minus 2 state, so each chlorine will be plus 1 state. So fourth option is the option where you will find chlorine in plus 1 state. Okay? Yes. Moving towards next question. In chromite ore, the oxidation number of iron and chromium. See, to answer this, you must be familiar about what chromite ore. So there are chapters in intermediate like metallurgy. Then there you will get familiar with the formula or the name chromite ore. It will be FeCr2O4. FeCr2O4. So it will be like Fe2 plus Cr2O4 2 negative. Cr2O4 2 negative. Now obviously, what is the oxidation state of iron here? It will be 2 plus. It will be 2 plus. Then what about chromium here? Let us 2x plus 4 into minus 2 is equal to 2 negative. 2x minus 8 is equal to 2 negative. Okay, so x is equal to plus 3. So here chromium comes out to be plus 3. So plus 2 plus 3. Okay? Yes, let's meet in the next video. Thank you.